Welcome to 3D Printing and Introduction, a program brought to you by the Orland Park Public Library. My name is Ian Lashbrook. I'm the Digital Services Manager at the Orland Park Public Library. That's my contact information there on the screen. This program is going to talk to you about the basics of 3D printing, some of the terminology that you should know, some of the things you should be aware of when designing 3D prints. We'll also point you in the direction of some software that can help you to create your prints and also teach you the fundamentals of 3D print design. This class won't really cover that. We're talking more just about the basics. And then if you check the links associated with the video, you'll see some examples of things that have some kind of crazy things that people are using 3D printers for, as well as some more resources for you to kind of get up and going with 3D print design. So what is 3D printing? It's basically known as additive manufacturing. It's a form of digital fabrication where we're using a computer-controlled tool to make a physical object. So instead of us creating the object with our hands, like you might with clay or paint or anything like that, we are creating a design and then putting that design using software into a computer, which then controls a tool, in this case the 3D printer, and creates your object from that model or design. It prints in a physical substance like plastic, which is the most popular form of what we call filament, and we'll talk about that in a little bit. Building one layer at a time to create a 3D object. So when these printers print the objects that you've designed, they print them one very, very, very small layer at a time, kind of stacking those layers one on top of the other. Designs are created using what is called CAD software, which is computer-aided design. Some of the popular ones that are available online are Tinkercad, SketchUp, and Blender. If you've never done 3D design before for 3D printers, I highly recommend using Tinkercad. They have a lot of good tutorials that will help you get started and kind of figure out how these designs should work and operate so that you create successful designs from the beginning. It's very easy to create designs that are unsuccessful. The printer does have limitations. And so if you're not careful and thoughtful with your design, it can create kind of scenarios where the filament goes all over the place or we're unable to successfully recreate the object that you've designed. Prints are generated from STL files, which is stereolithography. STL does not contain color information, which is really interesting. Typically, the average 3D printer has what's called one extruder, and we'll talk more about that. So it prints in a single color because there's only a single point of print for those layers we were talking about. Some printers have two extruders, which allows you to switch back and forth. So you could load two different colors into the extruders, or you can stop a print in the middle of printing and change out the filament and go with a different color, but we'll talk a little bit more about that. So terminology, I'm already using a lot of it in this program, so let's talk about some of the terms that we are discussing. There are a lot of brands of 3D printers. MakerBot is probably the most popular. A lot of local libraries use MakerBot 3D printers. At the Orland Park Public Library, we have two MakerBot printers. Another popular maker, a 3D print kind of company that makes 3D printers that a lot of libraries use is Lulzbot, but there's Robo, MakerGear, FlashForge, Ultimaker, Cube. There's a lot of them out there. And you can see them on even places like Amazon now. You can buy small personal 3D printers that are very, compact and can make small prototypes and things like that. 3D manufacturing services. These are places that you can take a print that you've designed and send it to them for fabrication, for creation. Stratasys, Diversified Plastics, these are places that will print a prototype or a design kind of en masse. There are also what are called kind of maker spaces. A lot of libraries now have maker spaces. And in these spaces, a lot of times we'll create your designs for you or help you print them, typically at a small cost to help recover the cost of material. But there's a lot of services out there now, even a service which like Thingiverse. Thingiverse is where people post a lot of their 3D prints. It's a really neat place to start kind of investigating 3D print design and how it works. Even on Thingiverse, you can connect yourself with a maker, someone who makes creative things. You know, it's a very broad term, who may own a 3D printer or maybe a library, and then you can take your design if you don't have a printer and submit it to that person, and they will print it for you. So there's a lot in there regarding those services. Filament. Filament is what makes kind of all this go besides the printer itself. There are two popular forms of filament, ABS, which is short for, I'm going to get this totally wrong, acrylonitrile butadiene styrene, which is a thermoplastic used as a 3D printer material. This is what a lot of people used first when 3D printers first became kind of commercially available. There are some questions about it's more durable, but there are some questions about the fumes and things that occur when you're kind of using it, because you are essentially melting and remolding plastic, and as we all know, you shouldn't really burn plastic. So this filament was popular at first, but a lot of places, including the Orland Park Public Library, has since switched to PLA, which is short for polylactic acid, and that's a biodegradable thermoplastic polymer made from plant starch, and is kind of the most popular now. We use PLA because those fumes that you may get kind of strongly from ABS, they don't exist as much with PLA. It's still, there's definitely a scent when you're 3D printing something, but the PLA has been designed to be more environmentally friendly and just overall safer. So extruder, I've already talked about an extruder. An extruder is kind of one of the main parts of a 3D printer. It's a group of parts which handles feeding and extruding of the build material. In this case, in most cases, it's going to be filament. It consists of two assemblies, a cold end to kind of pull the feed of the thermoplastic from the spool. So filament comes in these long strands that are wrapped around a spool. So there's one part that kind of pulls that into the extruder, and then a hot end that melts it, gets it to the right temperature so that it can be molded and extrude out of the extruder. Overhang. This is very important when you're designing your prints. An overhang is a part of a 3D model without any support below it. Parts that protrude at an angle of over 45 degrees are generally considered overhangs. So you have to think about how something moldable works. If you're kind of melting this plastic, it has to reharden. So when it comes out of the extruder, it's going to be kind of malleable. It's going to be a little bit soft for a couple of seconds. It takes a little while for it to reharden. After the 45-degree angle is kind of key. If you're kind of at some point, if that angle is less or more, depending on what part you're coming from, if it's a steeper angle, you need something underneath to kind of hold it up. We call those supports. We'll talk a little bit more about that. But 45 degrees and kind of more upright, it tends to harden fast enough that you don't need a support. So kind of just think of general architecture. Unless the material you're using is incredibly strong, oftentimes you need support to keep something in place. And so it's the same with 3D printing. If the angle is too steep for the plastic to reharden in time, it'll start to kind of droop, and it won't be able to continue creating those layers that the printer is used to. And that's when we get what we fondly refer to as spaghetti monsters, because the filament starts to droop and you get these kind of strands that all start, wrapping all over each other, and it looks kind of crazy. And that's a failed print. It's not going to work. So filament, that's exactly what it looks like. I said, we're kind of talking about strands of plastic wrapped on giant spools. They come in all different colors. There's all different brands. A lot of times the brand of printer that you buy, like if you buy MakerBot, they'll tell you that their filament is best for their machines, and in some cases it is. In other cases, there are kind of generic filaments that you can buy. I mean, you can buy filament on Amazon and it comes in all kinds of colors. There's also all kinds of strengths. There's different materials now. For instance, one of the things that the library has with its newer 3D printer is dissolvable filament. So those supports that you can create, you can put the print after it's done into water and the supports will dissolve, leaving a nice smooth surface on your print. The extruder. Here's an example of a 2 extruder setup. Most 3D printers will have a single extruder, but you can see there's a fan there for cooling filament. That small copper tip is what gets superheated to kind of make sure that the filament comes out. And then you, like I said before, you typically have a series of gears and things before you hit that heating element that pulls the filament into the heating element. And then here's that overhang we're talking about. So on the left, you have a much smaller angle. You're not going to need support. In the middle, you're starting to get to it. On the right is probably as far as you'll be able to go without needing to print something underneath that angle in order to make sure that it doesn't droop or fall or not successfully. Some more terms. Support material. This is what we're talking about. 3D models that have a large overhang or gaps between parts require support material to be printed, as it would be impossible to print into thin air. The support material is removed once the 3D print is finished in order to reveal the final print. So if you don't have dissolvable filament like we do, which we're lucky to have now, which is only a recent thing for the library, you'll print using the same filament, a hard filament, and then you'll have to snap those supports off, which can leave traces on your final print. The dissolvable filament shouldn't do that. A raft. So a raft is a technique used to prevent warping. A flat layer of support material is printed below the actual 3D part. As the raft is larger than the part, it has better adhesion. Once the 3D part is finished, the raft supports are discarded. So this is like a flat bed that the printer starts with to create a stable surface to print on top of. This raft oftentimes just snaps right off the bottom of your print when you're finished. The print bed. So this is another important part of the 3D printer. The surface of the 3D printer on which the 3D printed part is formed, also known as the bed or the build plate. And there are all different types of print beds and build plates. Some are heated, some aren't. For instance, the library's newer 3D printer has a heated build plate, which just makes for a little bit more consistent print. A lot of times people have to put things down on their build plate. A popular thing is masking tape or painter's tape to give the surface a nice adhesion spot for the print, and also to make it easier to tear your print off the bed when it's finished without damaging the build plate. Print beds and build plates, again, interchangeable term. They are very important when you're looking at, if you're purchasing a 3D printer, understanding what type of bed you're getting so that you can be prepared for how to best remove your prints once they've printed, really is the important part. Infill. So again, another important thing when you're designing your 3D print. The infill is the interior structure of a 3D printed model. To avoid wasting plastic, 3D prints are typically printed with an inner mesh structure rather than a solid interior. The infill is typically expressed as a percentage, like 20%. So imagine you were 3D printing a baseball. If you tried to print the whole thing solid, it would take an incredible amount of time. If instead you kind of do a lattice structure inside and you use infill, you can support the outer layer, which is the only thing you'll actually see, and the inside can be much thinner on material. It can be kind of this lattice that just helps hold up the outer shell. That's what infill is. It helps to speed up prints, and it's also more economic in the use of your filament. So support material right there, you can kind of see underneath the bird, there's all of those support materials. Those, when the print is done, you'll kind of snap off to have the final 3D object. A raft right there underneath the little Android robot. That raft creates, you can see it creates a solid, stable, flat surface for the rest of the print to build upon so that the print doesn't get warped. There's the print bed. That's a good indication of about the size of the average printer print bed, and is about the size of the print beds on the machines that we have at the library. And then here's your infill. You can see that lattice structure. You want infill to be appropriate to hold up your model, but also not be cost prohibitive. If you're using too much material, you're either spending money to have someone print it for you, or you're using your own material and you're gonna have to buy more. It's really important to find that sweet spot for infill on your designs to make sure that it's cost effective, but also maintains the stability of your print. So other things you might need an X-Acto knife for kind of prying the edges of your print off, or kind of slicing away little things. This can be a really useful tool, and a lot of like starter 3D printing kits come with one. Needle nose pliers for ripping rafts off, ripping supports off can be very helpful. A spatula, again, for kind of prying the print off the print bed. A lot of times your print is going to be stuck to that print bed. If it's a taller print and it's pretty solid, you may be able to just kind of crack it off. But if it's something that's a little more delicate, if it's a print that's a little more complex, you're going to want to use a spatula to get underneath. One thing sometimes we use at the library are old discarded gym membership cards or things like that. You can kind of slide underneath and get started. These prints do get really stuck to the print beds a lot of times. Glue. Glue is another thing that helps things adhere. If your print bed isn't heated or doesn't provide some sort of good adhesion, glue can be helpful to help the print stay in place to help the extruder kind of make sure that the print's staying in place as the bed moves and the extruder moves. Painter's tape. This is really important. A lot of people cover their print beds in painter's tape. It provides a kind of a barrier between the print bed and the print, so that nothing gets damaged, and it makes it a little easier to kind of snap those prints off the print bed when they're done. And the last thing there, sorry, I went a little bit quick, was the polyurethane. Polyurethane can be used to waterproof or water seal a print when it's finished, but you should only be using polyurethane on prints made out of ABS, not PLA. ABS is a much stronger material and can hold up to, you know, being coated with polyurethane. PLA prints, not so much. Again, only if you're trying to water seal, like create a vase or something. If you tried to print something with ABS that's a nice vase to put flowers in, and you poured water in it, water would slowly drip out of it. It's just the nature of prints, unless you have an incredibly nice 3D printer. But the average 3D printer is not going to print a watertight print. There's going to be very, very, very tiny holes that water will be able to get through. If you are using ABS, you should be able to kind of coat it in polyurethane, creating an actual watertight seal for that print. So what can you make? It was originally, 3D printers were originally designed as a way to create prototypes. And now with science fiction movies, you see them, you know, everywhere, and we'll be able to fabricate our needs in the middle of deep space. Whatever you like within reason. Toys, keychains, tools, 3D printers sometimes print 3D printer parts to build 3D printers. There's all kinds of things. Really, the sky is the limit, but also limiting you is the quality of your 3D printer. So what have others made? Houses. There's a video online where a 3D printer was used to kind of control the flow of concrete and help build houses very quickly by pouring concrete into already walled structures and things. It's really interesting. Prosthetics. This is really popular, especially for very young children who may need a prosthetic. There is a model out there to print kind of a 3D printed hand, and it appeals to children because its design is that it looks kind of robotic and claw-like. Again, there are videos online that kind of show this prosthesis and how it's created, and its appeal to young children who may need something like that. Replacement parts. This is a really popular way to imagine how to use a 3D printer. For instance, someone like Jay Leno, who has a lot of really nice cars. Those cars are old and may fall into disrepair or made really weird specific parts. If he's able to get the blueprints for those original parts, which a lot of the car makers still have, he can design, or have someone design for him, a replacement part for that car. That replacement part doesn't exist otherwise. So you can imagine how a 3D printer in that type of situation can be very useful. Sculptures. There's some really interesting ways that 3D printers have been used to create art. And some of that will include with the links for this video. But people have been designing art using 3D printers and CAD designs for a while now, and it really can come up with some really interesting stuff. So as we said before, there's a couple of really popular online, a lot of times free versions of CAD software. You obviously have to pay if you want, you know, all the bells and whistles for some of this software, but you can, in many cases, start with a free version to kind of get comfortable with it. And if you've never tried creating a 3D design before, I highly recommend Tinkercad. Tinkercad is very easy, simple to use, and they have a lot of good tutorials. Once your skills are a little bit better and honed, you can try SketchUp and Blender, which are kind of natural increases in proficiency and give you higher levels of detail. But be aware that your print quality is only as good as the printer you're actually printing the object on. So don't over design something if your printer can't create the detail you're trying to create in your design. One thing we've heard a lot of during the current COVID-19 pandemic is personal protective equipment. And you may have heard stories about makers, who we've already mentioned, all around the country using 3D printers to create personal protective equipment. They're manufacturing certain types of PPE. Local news places have been running these stories. The library actually donated all of our excess filament to one of these groups. We wanted to help in the way that we best could, and these groups, the one that we donated it to, already knew how to print these things. They already had the designs and were successfully printing PPE. So we donated our filament to them, which is what they needed. They needed the supplies to keep printing. Those supplies they're finite. They run out, and with all of the shipping delays on things, we had a small stock of filament that we were able to donate to one of these groups so that they could make personal protective equipment for the folks in the Chicagoland area. I want to thank you very much for joining me for this program on 3D printing. I hope you found it informative. If you have any questions, my contact information is there. Again, my name is Ian Lashbrook. I'm the Digital Services Manager at the Orland Park Public Library. Thank you, and be well and stay healthy.